AAGATE, a NIST AI-RMF-aligned governance platform for agentic AI.
Agentic AI systems can browse the web, write code, and use production APIs. The paper describes this capability as intoxicating for engineers and terrifying for security and compliance teams. There's a fundamental conflict here. The speed and autonomy that make these agents powerful also introduce new, serious risks.
And that brings us to the core problem. Existing security models just weren't designed for this. They were built for deterministic software, not for autonomous systems.
That's right. A traditional app follows a defined path. An agentic system doesn't. It can reason about a goal and then improvise a sequence of actions to get there. When you combine that improvisational ability with machine speed, you get a completely different security challenge.
So what are these new attack surfaces? What vulnerabilities are specific to this model?
3 new classes of risk are identified. First, logic layer prompt control injection, or LPCI. This is where malicious data hidden in a tool's output is consumed by the agent, causing it to take unintended actions. Second is cognitive degradation, or QSF, where an agent's performance becomes unstable over time. And third, digital identity rights misuse, DRF, where an agent could, for example, use a voice clone without the proper authorization.
To solve this, the approach doesn't start from scratch. It's built on top of an existing risk framework.
Correct. It uses the NIST AI Risk Management Framework. The role of the AI RMF is to provide the high-level structure, the what and the why, of risk management. It is not a technical implementation guide. Think of it as the blueprint, not the building materials.
The framework has 4 functions. You start with govern to set up the risk management culture. Then you map the context to find potential risks. Next, you measure and analyze those risks. And finally, you manage them by allocating resources to fix the highest priorities.
Okay, so the challenge is taking that high-level blueprint and turning it into a concrete technical system. That's the purpose of the AAGATE platform.
Exactly. For the map function, the platform uses the CSA MAESTRO framework for threat modeling. In the architecture, this is implemented by forcing all external tool use through a component called the tool gateway. This gives you one central point to see and control interactions, which is where you'd identify risks. Host B. For measure, there are 2 parts. A behavior analytics profiler watches the agent and generates security signals. Those signals are then scored using the OWASP AI Vulnerability Scoring System, or AIVSS. Then a governing orchestrator agent uses the SSVC decision-making framework to determine the right response based on that score. And to manage risk, the system uses principles from the CSA's Red Teaming Guide. This is put into practice by a component called the Janus Shadow Monitor Agent. It performs continuous internal adversarial testing.
So beyond just integrating these existing frameworks, what new architectural patterns are introduced here for autonomous systems?
The Janus Shadow Monitor Agent is one of them. It acts as an automated red team that's always running inside the system. Before a high-risk agent can execute an action, its shadow agent reevaluates the plan. It's a constant pre-execution check on the agent's reasoning.
And how are the actual external actions controlled? Through the tool gateway. This is described as the single most critical architectural control. It's a mandatory choke point for any external operation, HTTP requests, database queries, file I/O. Nothing happens outside the system without going through this single auditable gateway.
The flow is built for security. The agent doesn't call the tool directly. It sends an action request to a Kafka topic, which decouples it from the execution logic. The tool gateway picks up that request, checks it against policies like allow lists and rate limits, and only then executes the action. The whole transaction, request and response, is then logged to an immutable audit trail.
So those patterns govern agent behavior. How does the architecture itself address known LLM vulnerabilities?
The design directly mitigates several OWASP risks. The tool gateway performs input validation to counter prompt injection. The system uses a SLOSA Level 3 pipeline and signed container images to harden the supply chain. And because all tool use is mediated by the gateway, it can enforce purpose-bound OAuth 2 tokens for plugin security.
All right, let's distill this down. For an organization looking to implement something similar, what are the actionable takeaways? There are 5. 1. Adopt a formal risk framework. 2. Centralize all external system interactions through a single gateway. 3. Implement continuous, automated internal red teaming. 4. build on a zero-trust fabric with a secure supply chain. And 5, translate your governance policies into machine-readable code.
It all comes down to a final question posed by the work. Is your governance as dynamic as the agents it oversees? The point is that, for these autonomous, machine-speed systems, static checklists just aren't enough anymore.